Have you ever had your arcade stick get KO'd by your puppy chewing the wire, or even a phone charger just tripped over by someone and it no longer works? Well, today we're going to fix that. It's really easy to do. All we're going to do is cut away the damaged portion of the wire and then join together or solder back the 4 wires that connect it. To start, we're just going to cut off the afflicted portion, and then we're going to rip and strip the cable. To get rid of the outer insulation, I just cut at the wire, but not all the way, so that I can bend it and pull back the insulation. So once that comes off, with a little bit of effort, you may need to employ pliers to get this off, but I'm just going to tear at it till it comes off. Now, depending on your USB cable, there's going to be a bunch of junk sometimes with your wires. This has shielding and some fuzz with it. We're just going to pull this back and then trim it off with a pair of scissors. There's our 4 wires that we want to expose. The rest of it we don't really care about. USB cables follow a standard for wire color. The colors will always be black, red, green, and white. So now we're just going to take all that extra fuzz and junk off by trimming it off with a pair of scissors. Just like so. Once the wires are exposed, we're going to need to strip them to expose the metal of each wire. You may also need to employ some very high gauge wire strippers, about 28 gauge. Or if you can't find those, you can also use a pair of automatic wire strippers. Strip each wire just a bit, like so, just exposing a little bit of wire. In fact, that's a little bit too long. You only need a few millimeters to get the job done. That's good enough. Repeat this with all 4 wires on both sides. Now that our wires are stripped, we're going to melt a little bit of solder over each of them to ensure that they'll stick together better. This process is also known as tinning the wire. I just leave my soldering iron on the stand as I do this, and then melt a little bit of solder over the tip while bringing the exposed wire to the tip as well, so that the solder can melt freely onto it. Now we just repeat this with the other side. Now that we've tinned the wires, and that there's already a little bit of solder on each of them, we don't need additional solder to bring the 2 wires together. Now I leave my soldering iron on its stand as I melt the existing solder on the wires back together to join them together. Naturally, you want to solder black to black, red to red, etc. When you're finished, you'll have something that looks like this: 2 wires firmly soldered together. Now, to prevent any short circuits and any of the exposed metal touching each other, causing a lot of problems with your USB device, we're just going to cover it up with some electrical tape. Now, just struggle to find the end of your electrical tape for a few minutes, like so. There you go. And just snip a little piece off. You don't need very much to cover up the exposed metal. I'll just wrap it around the exposed portion to protect it from the rest of the wires. So while you're doing this, be sure to forget where your soldering iron is, so that you are very likely to burn yourself while you're attempting to wrap this tape around, just like this. Then afterwards, just move your soldering iron a little bit back so you don't burn yourself again. Good job! Then uneventfully finish wrapping the tape around the exposed bit of the wire. Also be sure not to go get ice and finish up the job while you're still working, because that is so much more important than anything else in the world. Once you finish taping them together, just repeat with the other 3 wires. Once finished there, just wrap it up with a little bit more electrical tape to protect all the wires. When you're finished, it should look something just like this. Repair complete. But what if you actually want to replace your cable and avoid the whole tape mess? Well, go straight to the circuit board. The 4 wires will be soldered on. The process is completely similar. All you have to do is remove the old wire and put on new wires. Now, where to get new wires? Well, just any old USB cable that has an A-type male ending. It could be from an old printer cable or extension cable, whatever. The other side doesn't matter. As you can see, I've already trimmed mine off. Now, do remember this is what you're going to be replacing it with, so be sure to get one with a length that you prefer. Now, sometimes, like in some models of Xbox 360 controllers, they use a harness, but that's okay. We can fix these as well. We're just going to look at this case first. Now, sometimes you don't even need to solder to do this. You can use a barrier strip if your device can fit it in. This is especially the case of some arcade sticks. Now, for this case, I'd prefer that you use a European style barrier strip. I'm using an American style because it's just what I had laying around. American style barrier strips should be used with spade connectors, while European style just require being screwed in. This makes them a somewhat better choice for your repair. Now, to start, we're going to cut the wires and leave a good bit of length so that we can fit them into our barrier strip. This is important. If you cut them too short, you may not be able to use a barrier strip, and that means you'll have to solder to repair. Same as last time, we have to strip the wires a good bit. But this time, since we're using a barrier strip, we're going to strip them more than before. Since we're just screwing this in, you don't have to be too precise about how long it is. Just be sure that there's a good bit of length so that you'll be able to get a good connection whenever we screw the wires in. This is about how much we should be using. As you may have already figured out, a barrier strip just works by screwing down wires and then connecting them to the side that's opposite of that wire. This way we can connect 2 wires together without having to solder. Also, this means the order doesn't really matter, just as long as the other side matches up. Now, what do the colors of the wire actually mean? Well, each wire has a specific meaning, and each color is standard across every single USB cable. Red is the 5-volt positive side. Sometimes silk screened on the circuit boards is V or 5V. White is also known as data minus. Sometimes silk screened on circuit boards as D minus. The green wire is data plus, or sometimes screened on circuit boards, D plus. And finally there's black, the ground wire, which some people could compare to the negative side of a battery, comparing it to the 5-volt positive of the red wire. Now, sometimes this is screened on a circuit board as GND, or just G. Now, every PCB, that is, printed circuit board, is different. Some circuit boards will have the letters printed as the colors of wire, that is, R, G, B, and W. Other PCBs might not even have it listed at all, so always be sure to write down the order of the wires. Or, sometimes you can just leave a little bit of the wire still soldered on. That way, you'll always know the order of the wires, and that way you won't screw up and mess things up and get things disconnected and not working because you just didn't solder on the wires right. For example, connecting 2 wires together that weren't meant to be connected together could cause a short circuit, and that could cause a way too big draw in current. and USB devices can only draw up to 500 milliamps of current. Any more, and the host device must be able to disconnect it. If the host device cannot disconnect it, then it is not able to be on the USB standard. Also, I spoke of spade connectors, and I'm not really using them. I am cheating, I admit it, but I'm just trying to illustrate the point. If you're going to screw down wires, just use the European style barrier strip. These American style ones, whenever you just screw down wires, can sometimes slip, and that will cause your device no longer to work. So always be sure to use the right tool for the right job. If you have spade connectors, go ahead and use the American style. If you don't, just use the European style and save yourself the hassle. Continuing on, we just screw on the wires corresponding to each color wire on the opposite side with your replacement USB cable. Once you finish up, you should have something that resembles this. The wires on each side screwed in, and all you have to do is stuff that back into your arcade stick. You may want to tie a knot in the cable before it exits the arcade stick to prevent it from being damaged. These are the insides of a Hori EX2 that was brought in to me to be repaired. Among other things, the USB cable is no longer working. The cable had taken a pretty bad beating, and that was also exacerbated by the fact that there wasn't any solder holding the wires together. Among other things, I just soldered back the USB cable in the method that I'm about to show you. I also tied a knot in it, as you can see in the top right hand corner. This is to prevent it from further damage. Now, we can just remove the old wires by desoldering them from the original circuit board. I'm just going to pull them off without using a desoldering brake because it's not really very necessary. All we're going to do is heat up the wires a bit and then remove them one by one. As always, be extremely careful and make sure that you aren't making any solder bridges, and if you do happen to make one, be sure to clean it up. Now with your replacement cable, the wires that have already been stripped and tinned, simply lay one across the point you're trying to solder to. Heat up the existing solder right there, and it should melt right on top of the wire. Once finished, you should be able to tug on the wire, just to check and make sure that everything is securely connected. This is good. Repeat this with the remaining wires. Also, be careful for solder bridges, and know how to fix them. If you don't know what I speak of, check my soldering tutorial video. After all 4 wires have been soldered on, you'll have something left like this. May not be quite as pretty, but that's okay. It'll work. Now sometimes PCBs may use harnesses to connect the USB cables, like this Xbox 360 game controller. But you can see right there on the back, opposite the side of the harness, are points that we can solder to. Alternatively, like with some Hori sticks, if you can find an existing harness that matches it, you can usually just plug them in and swap easily. However, finding one is hard, as you need to get this out of an existing Hori stick. However, it's a lot easier just to solder on a new USB cable. Now, when we flip it over, remember that it's going to be opposite the direction it is. So, for example, the black ground wire, which is on the bottom of the harness, when we flip it over, is actually going to be on top. This is a lot easier to visualize whenever you actually have the PCB in your hands. But after this point, it's just remembering the order that it's in. Now I'm just going to pop out one of the analog joysticks to make it easier to solder to. These pop off and on really easily, so don't worry about it, I'm not breaking a thing. I'm just removing it because it's very close to one of the points I'm going to need to solder to make it easier on me. Now the process is almost exactly the same as we just had done. This time though, we don't have to remove any wires beforehand, we'll just solder on the new wires. Be sure that they're stripped and tinned beforehand, just as we've been doing. And now the black ground wire is firmly soldered on. Next up is the red 5-volt wire, and this is not the same with every circuit board. This particular one goes from the black wire to the red wire, to the white wire to the green wire. However, it will vary from circuit board to circuit board, so be sure to check in between each soldering. Continue the process on with the remaining 2 wires, just as we've been doing. When you're all finished up, your USB cable should look something like this, soldered to the back. Now, before we plug it in and test it, we just want to make one more check on the back to make sure that the wires are correctly soldered on to their corresponding color. So, flip it over. It should be the reverse order since we soldered on the other side, flipped over. There we go. Everything's working great. So now we just need to test it. To test it, we'll just plug it into my computer, make sure that everything's working alright. USB cable soldered on right there. LED for one player comes on. Game controller properties. Here we go. And we can check the properties of the joysticks just to make sure that they're working. I'm just moving it around a bit to make sure that everything's fine. Mess with the triggers a little. Still working. Maybe press one of the bumper buttons that are still attached. Lights up when it does it. Everything looks great. Repair complete. Now sometimes on some game controllers or arcade sticks, especially in the case of Mad Catz produced arcade sticks and controllers, you'll see that there are 5 wires, 2 of them being black. The thicker black one is shield ground and it's completely unnecessary for a repair. The other 4 are your standard USB wires that work just the same. And as you can see with the harness, you can flip it over again and everything will be the same. Just to demonstrate, I'll do this one more time. Just as before, have your wires stripped and tinned, ready to go beforehand. And just repeat the process as we did with the last harness type game controller. This is just a different model of Xbox 360 controller, but the process is exactly the same. In fact, this process will be the same for any USB device. Just use the same method and principles. Reconnect the wires where they're supposed to go. Since arcade sticks kind of are my specialty, I just have a lot of random Xbox 360 controller guts laying around, which make them perfect candidates for a repair video. Continue the process just as before.
Walk like I made you fly. You walk like I know when you're good to
Once you reattach the 4 wires, excluding the shield ground wire, everything should work just fine. Time for a test. Nothing new here, just plug in the new USB cable into your device. In this case, I'm just using my computer again. Player 1 LED comes on just fine, and there you have it, right there.